Hello everyone. I got my new angle sensors. They're, they're in a bit bigger package module than the other ones. As you can see here, this is my the ones I've been using. These ones. Let's just get that focused about there. That's it, yeah. So you can see this one, and it only uses 4 wires. This one is run on I2C, so we had our power and ground, and then we had our clock and data. These ones, right, obviously you can see these are a massive compared to this size. So let's just put that to one side. Oh, right, so I'm obviously going to have to modify this. So this was my my joint, and that went in there like that basically. So now what we're going to have to do is fit this into the same place like that sort of thing. So I'm going to have to put a bigger opening. Now these came with these magnets. I didn't get magnets with the other ones, but I've got these little magnets here, and actually even though they're round, the north and south go in that direction. As you can see, they're all stuck together like that. Yeah, what I want to do is test first is if the original magnets I have will work. Yeah, so the best way to see if these right, the other thing is, can you see we've got lots of choices of how we're going to connect up. So we've got them there. What I'm going to use, this side with the 6 on. I'm not going to use the M, that's for mode. And also on here, if we look close, can I just see there? Yeah, zoom in. You see there's a thing missing. Well, that's there is to put a, well, I suppose you could put a 4.7k resistor in there if you wanted to ground the mode. So that is, this here is just from the mode on the chip, or the mode pin on this breakout here, and it takes it to ground, so it just grounds it out. The chip has an internal pull-up resistor that pulls the mode up to VDD, so we don't need to do anything about that. So we can just yeah, just leave this mode alone. So what we're going to actually need now is we've got 1, 2, 3, 4, 5 cables we're going to have to attach to this, because we've got the power, which is VDD, and then we've got the ground, which is G, and then we've got this A, B and Z. Now they have different modes, although it looks like there's lots of pins here and different pins here. A lot of them are shared. So like this is the, if we were going to use I2C, we would use these 4 pins here, but that SCL and SDA, you know, I could connect it same way I've connected this, but it's going to be slow. What I want to do is I want to speed it up, and so this is why I'm going for the SSI, ISS, SSI. Anyway, we'll get that right in a minute. But anyway, it's just a serial data and a cable select, and that's what these 3 pins are going to be. But there's a slight there's also a little trick that this chip uses, so you can use them 3 pins as right instead of just constantly reading from it. Anyway, I'll come to that as well. So yeah, it's quite a clever little chip, this. So let's have a look at the data sheet. Yeah, so here's the data sheet for it. Now you notice there's 2 chips. I've gone for this one here. You can see there's a lot more pins on it. We've got what, 4, 8, 16 pins, whereas there's only 8 pins on here. although there's 16 pins on here, 4 of them are not used, so we've got 12 pins that are used, and we've only got 8 here, so this one has got extra 8 pins, which means it's got extra 8 connections you can use. Not they're going to use them, like, but they're there if you want. Just ignore this for the moment, this 1024, because that's just the ABZ resolution, which we already have. This is the 12. No, that's 1024. No, I'm talking about my ass. Hang on, forget that. Oh yeah, that's the pulses, yeah, which gives us a, if we look down here, which gives us our 496, which is what we already have with the current sensor that I have. But this is for the ABZ output, and what we're going to be using is we're going to be using this bit here, which is the 14-bit absolute angle position data. So we're using SSI. That is a bit like, what is it, you probably know, SPI, serial peripheral interface. Well, this is just single serial interface, which means it just goes in one direction and not both. So basically what we're doing is we're constantly reading data from the chip. So we're not actually sending any data out, so it's like half an SPI. Anyway, but we're getting our 14 bits. And the other thing about this chip as well, it has push. It's a virtual push button. So if the magnet goes, if you have this that rotates on a button, say a rotating button, and you can push the button down so it moves the magnet closer, it registers as a button, and so there is another pin out for the button, which is why I went for the other chip. I think this actually has the button as well. Power supply. Oh yeah, there we got push. There we got the pin 5 is the push button effect on there. But I've gone for this chip, this one here, because although the first 4 pins are not connected, we do have a lot more choices. And you know, it's a breakout board for playing around with, so let's play around with more choices. Anyways, so yeah, that's it. So we've got that. Let me get rid of that now. So the first thing I needed to do is to see if it actually fitted in what I already have. I don't want to have to rebuild the whole 3D scanner again if I have to, so we'll just see if it'll fit. And it just fits, but it catches these bolts here. So what I'm going to have to do is I'm going to have to grind a little bit away on the actual modules to allow these screws to go in, and then I can use the same thing. The only other thing also is that these pins is the position of these cables that come through here as well. So because I've drawn it in my model, and I always believe in drawing stuff in the model, don't just take it for granted the measurement will do. You need to actually see and see if it'll actually fit. So what I need to do first is also, once I've fitted one of these, is check that it works with the magnets I have. So if I remove that, you can see the magnet I have one of these square magnets, and it has the north and south going in that direction. I need to check that this works okay with this sensor. So what we'll do is we'll just have that sensor in there, and what I've done is done arm axis 1, and we can see the sensor behind there. Let me just move that. That's the old one in there, so I'll just leave that as it is. But we only need one, so there's my sensor, my new sensor inside this arm, and you can see, I can see here that the cables only just come through where these pins are. So we're going to be okay, but what I'm going to try and do is I'm going to try and move them further in, so they're closer to the center here. I'll show you that once I've soldered one up. So yes, so it looks like it's going to work if I do them 2 mods. So if I do the 2 mods, I make room for these screws to go through, and I just try and move these wires that way a bit. It's all going to fit in there. So with the new plastic thing, which I've made a few of, let's go back here, and we can see here there's one I've actually made. Let me just take this off here. So you can we see there? Let's just get that to focus again. So if we look at the sensor, we can see that there's no pads on this side. There's virtually no pads. I think these are supposed to put like sockets on it, and then you solder the sockets in. But having them on this side defeats. You're going to get in the way of the height of this. Anyways, so I have to put my cables on there. So what I've done is I've soldered them. Let's get one that I haven't soldered so we can compare. Yeah. So you can see where the holes are. So I've drawn in my drawing those holes needs to come this way a bit. So what I've done is I've soldered my wires in this direction, just on top of those, and that way when my wires should come through that oval, hopefully. Anyway, so the first thing to do is I've also made a new plastic frame. This little edge didn't come out when it was printing. I've got it set at 0.4mm width, I think, so that was a bit less than 0.4, so I didn't do it. But anyway, that's not a problem because that fits in there nicely. Oh yeah, I nearly forgot. And can you see the edges? I've just trimmed them away. What I did was I've got this neat little polishing thing. It's a USB thing, and I made a jig for the end, put my little grind wheel in, and what I did was, can we get that in? Yeah, so I just come in from the edge. Oh, that's a bad one. That was one of my first attempt. Yeah, that looks better. So basically what I did was I came in there from that end. I'm going to get it in the right place. And that way I get them all. So once they're all in my jig, there, can you see? It lines them all up. So I just turn it over and do that one. Do the same there. Slide it in until it actually goes into the thing, and then swap it over that way, and this one then comes in there, and then back over that one for the last one, like that. And that ground all the way the edges. So yeah, having a nice tool like that, 3D printer, a jig, and that enables. So when that's sat on there like that, you can see that the hole is clear. Yeah, you can see the clearance for the screw to go through. So I'll just tape that in place, to hold it in place. And what I've done is I've done an Arduino sketch. To test, because I want to test that the magnets that I've got in there are okay. So what I can do is I can just put that down like that. Let's get it focused in, and we can turn this, and let's bring up the serial monitor of the Arduino. There we go. Just clear that. Yeah, we're working. Oh, and it also checks the field as well, so we can get a signal to check how strong our magnet is and see if our magnet's alright. So basically, because it says normal, I know my magnet's normal. One moment, I'm going to cough. There we go. So what we can do is we can turn this and we should be getting more accurate readings. So now if I turn it around, we're at 360, excuse me, 360. There we go, I passed it, but oh, right delicate there, look. So what I should be able to get here is, if I can move it gentle enough, is, oh, I'll go the right way, I am. Oh, the whole thing's moving. Right, oh, my hand's it way, this is it way, isn't it? You can't see what I'm doing. Right, there we go, let's just hold this bottom bit still. Right, you can see that I'm only moving it a really fraction, and I should be able to get it down now if I can move it just that little bit there. Right, 0.22. right, that's that there, that's so that's 0.022. that's my lowest number I can get. So the next one should be 0.44ish. I'm too far. I'm hardly moving this now, so we can see that it's which way? Jesus, I'm only moving it a fraction. Oh well, we've got 6 there, so that's like 3 steps. Let's see if I can get slightly slower, just a real fraction. Trying to move it. Oh, no, I went too far. But obviously, I could go through. Oh, right, 2.2. Gonna get the 2.4. Oh, right, yeah, there we go. 0.439. There we go. And then obviously we go up to this 0.06. Wow. 0.65. Yeah, I mean I'm moving at really fraction. So obviously it works, and we can see. But you can see when they're all lined up that it reads some stupid number there. I don't know what's with that, but the thing is I will be able to calibrate that and set that as 0 as well, because we can actually write to the EEPROM. There's an EEPROM on the chip that we can write to, and we can say, right, this is our 0, and that's what we'll do once I've got them all set up inside the 3D scanner. Right, yes. So yeah, so what I'm doing at the moment, I'm just going through all these. I've printed all the new ones out. That's the old one for that. And so what I'm going to do is I'm just going to solder these up so they all look like this here. But there's going to be 5 wires. So yeah, that's going to change. So let me just bring that up. Yeah, remember this this sketch. Not very interesting, but the thing is, it's going to be wide different. Now you can remember that I had to do a data and a clock for each sensor last time, and it all went into that like I2C switch at the bottom here. Well, this is going to change, so what I'm going to have, I'm not going to have that one. Let's get rid of some of these. Yeah. Right, so with this, that looks better. Right, I'll just tidy it up so you're not watching me do a load of crap. Yeah, I've tidied up the wiring now. So you can see that we've got the 4 cables, and every one of these are all shared. So this time what we've got is we've got the 5 sensors, and we've got the ground, the VDD, and the clock and the data, and each one is shared. So basically that we're all connected in parallel. So each sensor is connected to the same data lead. Each connector is connected to the clock lead. Each sensor is connected to the power lead, and each sensor is connected to the ground lead. So they're all connected. Now, whereas before we had the switch and we had the two separate clock and data to each one, now we've got the same wires going to each one, but we've got a fifth wire. We've now added an extra wire. So what we need to do now is from each sensor we actually have a chip select. So for each chip we need a chip select wire. So what we'll do is we have another wire coming down here like so for that one, and then we'll have another wire coming off this one here like so for this one. And this one will come here, and then we'll have another wire coming off this one here over here, down here, and down here for that one, and then we'll have another wire coming off this one across and along and down and down, and for that one there, the fifth one coming up here. Coming along and down and down. So what we now have is I need to change the wiring loom that I have for the old sensors and create this new wiring loom. I'll try to use what I had before. What I'll do is I'll unplug it and put a 5-pin plug on the end of each point. But you can see now that the wires have changed. The clock and data are all shared between each one, so I don't need a separate one for them, but I do need a separate wire to select each one. So my microcontroller can use one of these cables here to select which one sensor it wants to read, and then it just reads the data off these clock and data leads. So all it has to do is go click click. So I need 5 pins on extra on my microcontroller to select each individual angle. Okay, so that's that bit. And before I go with this, so I'm going to go and do all this. I'm going to do all the soldering up and remake the loom, make up the new angle things. And before I showed you when I was using when I bought this, it was cheap. It really was cheap, and it came with these on, which are, let me have a look. These are what I was using last time, and the fact is it has the small one which did the DuPont. Let me just focus in on that. Can you see that's the small one, and that fits in there like that. And I forgot what oh right, it's written on the actual tool. This is the SN58B, which was in them, so that was the 58B. But if you look on this, you'll notice that they're all the same width, even for the little tiny ones. I mean, the tiny ones are going to be a bit shorter here. So what I did was I found another set of these, which is more for my style, and that's what I've got in here now. I don't know if you can see the difference. What I've got is I've got a smaller one than this. Now that small one there is the same as this one here, the second one in, but now I've got an extra smaller one. And what you can see here also is, don't know if you can see that, but the smaller ones are actually narrower than what these were. So if I Which one are we looking at? That one. So if we look at that, you can see these are much better because it's wide for the big one, and then it goes smaller for the next one, and narrower for them, and narrower for them. This one is much better than what I had before. I've forgotten what this version is actually, but you can see that it actually steps down in thickness, and it's much better. And this small one, I'll be able to get this thin wire as well. I can get the thin wire with this small one and all, because it's, what is it? Yeah, because my original only went to 0.25, now it goes to 0.08, so it's a lot thicker. Which, what's that in AWE? AWG, shall I say? Yeah, AWG, it's 28 to 26, so it goes down to 28. Is it 28 there? I mean, I'm using 32, but it's pretty close. I just have to double it up. 32 will get me 28 then. Yeah, I don't know what they're called, just give me a minute. Yeah, this is the one I ordered, the SN2549 from here. But if you look at it though, oh, where's it gone? There. Is that the one? Yeah. Where is it, that one? Yeah, it's that one there. Right, yeah, so yeah, it goes down to 08, but hang on, let's just move that across and get that into. The ones I received are far better. These are a lot better. Well, that's what I ordered because I wanted the 0.08, and in actual fact I got something even better really than what it shows there. So I mean, we know that the Chinese use stock photos, so yeah, well, try your luck. That's who I got them from, and I ended up with these, and you can see that they change width to depending on the size of the actual crimp. So yeah, this is the ones I've got are the better ones. I was expecting these, and it only looks smaller there, but it actually is staggered going down. Anyways, I digress. But I don't know if anybody was after them. Where are we? How do I get out of that? Right, yeah. So it was from. It was sold by them anyway. So. And that's what it was. So I wonder if anybody else got similar to mine, but oh no, they've got different things. So unless they've ordered the same as me, I don't know. But anyways, yeah. Yeah, right, okay. Sorry guys. Right, I'm going to leave it at that anyway, and I'll catch you once I've done all the modifications to the 3D scanner, and fingers crossed, let's hope this improves it. Catch you later guys.